Hello, this is Semantic Web Technologies. Today, we start with Lecture 4, Knowledge Representations. In the first part of this lecture, we will deal with the concept of ontology. And ontology as a central concept in philosophy. This is where the concept stems from. So, what does ontology mean and why are we using it? First of all, let us start with the fact that people cannot communicate and cannot share knowledge if they don't speak a common language. So this is pretty important, as you can see here in the picture of the Tower of Babel, where people were not able to communicate because everybody was speaking a different language. So this is very important that understanding is only possible if you speak a common language. But what does it mean to speak a common language? This means that you are using common symbols and concepts, and this has to be defined within a common syntax that has to be used. And on the other end, of course, there must be an agreement about the meaning of these symbols and concepts, so you have to define a semantics. And to this also belongs that the concepts you define and you are talking about are classified somehow. What is a sub-concept, what is a super-concept? How are they connected with each other? You can do this with the help of so-called taxonomies. And you also have to state which things are related with other things, with other concepts. So what associations are there, what relations are there between concepts? This you can find, for example, in a thesaurus. And if you have relations and associations between concepts, the next thing that you can do is you can formulate axioms about certain restrictions. When does a relation make sense? When does it not make sense? What restrictions are connected to a given relation or to a given association? What makes sense? What is true? What is not true? And these rules, these axioms, they have to be or can be expressed in the sense of an ontology or several ontologies. So, this is what we are talking about. So, for the first thing, we want to share knowledge. So we have to define what is knowledge. To define knowledge, we have to look, or we have to take another perspective. First, in the world, there are some basic truths, things that are considered true. But you have certain beliefs, and not all of your beliefs are quite true. But of course, these two sets, they have a common subset, so they have an intersection. And within this intersection of all truths and all beliefs, there is this, what you know. So knowledge is a subset of all true beliefs. And thus for formal knowledge representation, or to represent knowledge, we need some formalism. So a formal knowledge representation, which is or which are ontologies. Okay, let's take a look back in history where the concept or the term ontology comes from. So it's a pretty old concept. Originally it's Greek, so it consists of the part on, which is the participle for to be, and logia, which means science in Greek. So in all, it's defined as the philosophical study of the nature of being, existence or reality, so as well as the basic categories of being and their relationship. So, you see, it's a philosophical discipline, and it deals with what is real in the world. So the basic question is, what does really exist, or what can be said to exist? So this is a question of so-called general metaphysics in philosophy. And this is in contrary to the viewpoint of the so-called epistemology. The epistemology only deals with things of our perception. So what we see, what we hear is our perception. But often our perception is betraying us. We only can experience the world with our perception. But sometimes, as I said, the perception might betray us, so we have to know what is real in the world, what is true in the world. And to define what is really true, independent from our perception. So this is general metaphysics, and this is the part that ontology wants to define. So there are some fundamental questions in this science of ontology in philosophy. So in philosophy, one thing, ontology only is singular because it's a study. And in computer science, we will use the term ontology for knowledge representations. Therefore, there can be more. Therefore, it can also be plural. Okay, but first, let's take a look at the fundamental question of ontology. First fundamental question, what does it mean for a being to be? So this sounds quite funny or quite strange. But there are several related questions that are quite common. For example, when are two things identical? When can two things considered to be the same? So is everything that exists also real? Does something exist that is only possible? And on the other hand, are there really things that don't exist? So is this a possible concept? So these are questions that the ontology was dealing with on the one hand. And on the other hand, the ontology tried to categorize the whole world of being, into categories. So what categories of objects do exist? And there were some questions related to it. For example, do things exist that are only unique, that are only multiple in its existence? Do things exist that are unilaterally dependent of others? And which sort is this dependency, if there is any? And do so-called necessary property exist? And how do composed things relate to their components? So it's somehow to explain the world and to categorize the world and to bring structure into the world when you answer these kind of questions, independent from what you perceive with your senses. So independent from epistemology, only explained from our mindset. The term ontology itself occurs the first time here in the 17th century. Jakob Lorhat, for example, in this book, it's in Greek, Octuas Scholastica, it's called, he uses this term for general metaphysics, for example. And in German language, it occurs some years later here in Philosophical Encyclopedia. But the science of ontology itself, the metaphysics that is behind, that stems from ancient Greek philosophy. And this is where we want to take a first look at it. So Greek philosophy and especially ontology starts in an area in the 6th century before Christ, so 6th century BC. And one of the first philosophers that dealt with the question of ontology was Parmenides, and he posed the question, so what are the fundamental categories of existence? How can we structure the world according to the questions, to the basic questions that we have seen before? And after him, there is Socrates and Plato, two of the great philosophers from ancient Greek, and they had the idea, okay, reality is something completely different than what we perceive with our senses. So here is the first time this idea I have told you about. So they say things that we see in the real world, these objects of sensory perception, they are mutable, they are perishable. Of course, time is an important factor and they change within time, they perish within time. Though these are only images of so-called archetypals of the ideas. And these ideas, they are immutable, imperishable. They will never change. And these ideas exist only in our mindset. They exist in our mind. And the objects of the real world, they are simply instantiations of these ideal ideas. So if you look at it from the point of a computer scientist, the ideas are classes, for example, or objects, and the objects then are instances of these classes. So what Plato and Socrates did here was, in a way, they laid the foundations of object-oriented programming, of course. So because they decided, or they distinguished between classes and instances of classes. Instances are the objects of the real world. Classes are the ideas, so the ideal classes that are only existing in our mindset of the things. Next, from the Greek philosophers was Aristotle, and he joined this ontology club, and he asked the question, how can I structure the world, and how can I formulate, let's say, a concept of queries or a principle or a framework of queries that helps me to distinguish and to classify things in the world. So what he did is he defined a system of general categories for classification of all things about which statements can be made of. So he designed something that comes quite close to an ontology in the sense of computer science, which tries to explain the world, to put a system, a general system of categories and questions how the world can be structured. On the other hand, Aristotle also laid the foundations of our logic, of first-order logic, for example, with his so-called syllogisms. So this is the core of the Aristotelian logic, it's called, and these are sample inference rules built according to always the same pattern or template. So for example, you have the statement, all humans are mortal. This is the so-called major premise. And then you have a minor premise, which means all Greeks are humans. So all Greeks are humans and all humans are mortals. And the logical conclusion of that is that all Greeks also are mortal because they are humans. So this pattern, for example, this defines a pattern. And according to this pattern, you can do logic, because between the premises and the conclusion, you can do an inference. And you can do this inference with a simple machine. So it's always the same. You have here the subject, you have here the predicate, you have major terms, you have middle terms, and so on, and minor terms. And in the end, you come up with an implementation of a machine that is able, with rules that are expressed according to these patterns, to make mechanical conclusions. So this is pretty smart, isn't it? And this is the basic of our logic today. Okay, let's go some further. Let's go to the late antiquity and the early Middle Ages. Also, the science of ontology develops. Of course, also in the late antiquity and the Middle Ages, what the ancient Greeks did, what Aristotle did, what Plato and Socrates did was, of course, still valid and pretty much interesting for people. But it was difficult to understand. So, for example, this guy, Porphyr of Tyros, in the 2nd century, he wrote textbooks on the texts of the Greek philosophers, of the classical philosophers, for students that try to simplify and to visualize all these statements and all these studies. For example, also ontology. And what he did was he tried to make a visualization of the category system that Aristotle has defined. And therefore, he came up with something that is called the Arbor Porphyriana, which means the tree of porphyry, the tree of knowledge, where the categories of Aristotle, that of course were only at Aristotle explained in text, can be put into a visualization of a tree, and then it can be understood much more easier. So these systems, for example, are also used in botany, for example. So here we have a visualization of this interesting tree with all these questions and categories that Aristotle has proposed. And if you transfer this to a tree, how we visualize trees today, you see here you have a subsequent number of questions or categories that are related to each other, and with that you can decide, if you have a thing, you can order this thing into somewhere in a class that is represented by this structure that is given here. So this was a pretty smart invention, this visualization. Later on, in the Middle Ages, also Christianity was an important subject, but also the medieval scholasticism was referring to ontology. So they were referring also again to the Greeks, to Aristotle, who was canonical in some sense, and to Plato and Socrates. But they dealt, of course, with specific ontology problems that were related to Christianity. So one of these problems was the quarrel of the so-called universals. So the question there was, do universals, which means universal ideas, do they possess an ontological existence? What does that mean? So for example, a universal is the universal good or the universal evil. And the problem was, of course, there is some abstract concept of good and some abstract concept of evil. But does this also have a real existence in the world? So Thomas from Aquin or Anselm of Canterbury, they were dealing with questions like this. And of course, this was an important question because the ultimate good or the ultimate evil is extremely related to Christianity. So there were two different schools. One said that were the so-called realisms. Universals are real. They do exist in the real world. This, of course, will only work for, let's say, special categories. What is with the red, the universal, the red? Does the red, whatever this is, exist in the real world? I have no idea. And there was the so-called nominalists. And they said universals are nothing but words and symbols, so they are only concepts in our minds. So to decide who is right is pretty difficult, and this quarrel went on for several centuries. There's one interesting guy here in that row of saints. So the upper two, they were saints of the Catholic Church. This one, William of Ockham, never was saint, but he did something interesting for us computer science, because maybe you have heard of Occam's razor. So this is a simple principle from scholasticism, and it says that among competing hypotheses, the one that makes the fewest assumptions should be selected, because it's much likely that this one is the true one. So a theory is considered to be simple if it contains only as few variables as possible and as few hypotheses as possible. And of course, they should clearly relate logically with each other, and the subject to be explained can be logically deduced from these assumptions and variables. So it means take the simplest hypothesis, and this should be the right hypothesis. So this is the so-called Occam's razor. In Latin here it means entia non sunt multiplicanta sine necessitate. Entities should not be multiplied without necessity. Also in the Middle Ages, there were first thoughts about how to mechanize logic. Logic, according to this Spanish guy, Ramon Llull, is the art and the science to distinguish between truth or lie with the help of reason, to accept truth and to reject lie. So this is quite smart, even in a time in the 13th or 14th century. So what he proposed was, let's take this tree of knowledge from Porphyry, with the Aristotelian categories, and make a machine out of it, and consider this tree really as a decision tree. And therefore, we have the first concept of a machine that logically is able to put things into categories and to categorize the world. So this is the first logical machine. It was proposed by Ramon Llull in the 13th, 14th century here. Okay, one step further, we are in the Age of Enlightenment. And in the Age of Enlightenment, the questions around ontology became much more interesting. So for example, we had here John Wilkins. He was one of the founding members of the British Royal Society. And he realized that when people talk with each other, especially scientists, the problem is that many times they don't understand each other, because when they come from different science disciplines, they use different vocabulary. And he said, in general, the human language is not unique. It means it has a certain word has multiple meanings. So there is lots of ambiguity, and because of this ambiguity, scientific progress is slowed down, and in the end it becomes impossible because people do not understand each other. So what he came up with was the idea to develop a universal philosophical language with the goal to represent the entire knowledge of the universe with unique words, with unique concepts that have a unique meaning. So that when people talk to each other using this language, they really would understand each other, so there would be no ambiguity. But the problem was, of course, the definition of a language like that. So He didn't have the means of logic, and therefore it was really, really complicated to come up with a language like that, and this all remained a simple thought or an expose and was never carried out in practice. But next important person was Leibniz. Maybe you have heard of Leibniz. He was a genius, a mathematical genius in the era of Baroque in the 17th century, and he was also the first, or one of the first to develop a calculating machine. And he developed the idea, or he took up the idea of John Wilkins, and he said, okay, a universal language should consist of numbers. And let's take some so-called characteristic numbers to model Aristotelian logic in the hope to solve logical problems with the help of a calculus. So this was quite some interesting idea. So what he wanted to do was he wanted to uniquely identify objects of the real world and abstract concepts with numbers. And then he wanted to compose numbers and for example, he wanted to express things and objects as prime numbers, and then if you have in a single view or in a single image several objects that are represented by prime numbers, simply by making a prime factorial decomposition, you are able to distinguish what is directly in this picture or in this text. So this was quite an interesting idea, but the problem was he also had not the facilities of modern first-order logic. So it was not able, or he was not able really to fulfill his plans with this universal language. But on the other hand, really, if it is possible to develop a language where everything can be expressed uniquely without ambiguity, then each quarrel can be solved by computing the argument. So it's pretty simple. So it was a great idea. At last, let's take a look at Immanuel Kant, also from the Age of Enlightenment. He was a great philosopher, and most things that he had written are completely not understandable for the common man or for the common computer scientist. And he also dealt with the concept of ontology, and he wanted to structure the world into categories. And categories for him were pure concepts of understanding. And he defined 4 functions for ontologies, for categories, and he said, okay, we can distinguish quantity from quality, we can distinguish relation, and we can distinguish modality. We cannot explain what he meant by these terms in a single sentence because it was a long, really, he made long descriptions of these, of the meaning of these terms, and he made categorical systems, as you can see here. For example, quantity, he distinguished unity, which means one, plurality, which means many, or totality, which means all. So if you look at these certain items, the first and the last, they are somehow contradictory and or inverse of each other, and the middle one lies between them, or is something as a compromise. So in the end, this was also a category system where you are able to structure the world, to take something, some object from the real world, and to put it somehow in one of these drawers of these categories. And this is a mean to explain the world and to structure the world. Of course, the subject of ontology did not stop at the Age of Enlightenment. Up to today, there were many philosophers dealing with the question, what is real in the world and how can the world be structured? Maybe you are familiar with some of the faces here. Maybe you will recognize Friedrich Nietzsche or Arthur Schopenhauer, Ludwig Wittgenstein, Bertrand Russell, or also, for example, Ortega y Gasset, who is also there, or Jean-Paul Sartre. Okay, but this was a little excursus into philosophy. And from my point of view, also for computer scientists, it's important to know where the term ontology comes from. Because in the next part of the lecture, we will deal with ontology from the viewpoint of computer science, and you will see that we will always refer to some of the aspects that have already been laid on in the discipline of philosophy and ontology there. Okay.